Assalamu alaikum. Today I'm going to present the graph matching project of DSA data structure and algorithm. My group member are me Asadullah 25283, Waleed Ahmed 24895. So the contents that we are going to discuss are introduction, algorithm used, working of algorithm that we have used in this project, dry run, and pseudocode, algorithm used time complexity, algorithm used application. So first of all, I'm going to introduce about my project. So graph matching is the problem of finding a similarity between graphs. So we have to find a similarity between graphs, the two graphs that we are matching. Graphs are commonly used to encode structured information in many fields, including computer vision and pattern recognition. And graph matching is an important tool in these areas. So we use in our daily life applications like computer vision and pattern recognition. We also talk about bipartite graphs that are used to represent graph matching. We divide them into two vertices that are used for the graph matching. Now I'm going to discuss about the algorithm that we have used for graph matching. The algorithm we used is breadth first search. As we know that tree is also a graph, and graph is represented by vertices and tree is represented by node. Both are same. There is no difference between them. So breadth first search, we know that it starts from root and traverse the whole tree. But similar to that, there is a depth first search, which traverse the tree in three different types. It's in order, pre-order, and post-order traversal. So we are not talking about them. We talk about the breadth first search. So it is an efficient way of data search, but we have to search many times. So it is very cost effective. It starts the tree, root, and explore or node at the present depth prior to moving on the other nodes at the next depth level. Working of algorithm. So how this algorithm works? Start by putting any one of the graph vertices at the back of queue. What is a queue? Queue is having function nq first in first out. So take the front item of the queue and add it to the visited list. We take the front item from the queue and add it to the visited list that we have created an array of 5 index number, and same as a queue. Create a list for the next vertex adjacent nodes, add the ones which are not in the visited list to the back of the queue. Keep repeating step 2 and 3 as we discussed above until the queue is empty. The graph might have two different disconnected parts, so make sure that we cover every vertex. We can also run the breadth first search algorithm on every node. So now I'm going to visualize by pictures. This is a dry run. As you can see, there is a tree. We are considering 0 as the root node. So we traverse the tree from 0, then it traverses from 1 to 3, and then 4. So you can see there are 5 index arrays. One is visited and one is queue. Remember the function nq dq. So in queue we have 1 to 3. So we dq the 1 and it would go into the visited array. And now next we have the 2. Then we dq it and it will go into the visited array. Next we dq the third 3 node and it will go into the visited array. Next we dq the fourth and it will go to the visited array. So here we have completed the breadth first traversal of the graph. So next is the pseudocode and my group member will explain it.
Assalamu alaikum. My name is Waleed. Pseudocode. First, we will create queue, mark V as visited and put V into queue. While queue is non-empty, remove the head U of queue. Mark and NQ all visited neighbors of U. Algorithms used time complexity. The time complexity of the BFS algorithm is represented in the form of O bracket V plus E, where V is the number of nodes and E is the number of edges. The space complexity of algorithm is O bracket V. In algorithm use applications to build index by search, index for GPS navigation, pathfinding algorithms, in Ford fluxion algorithm to find maximum flow in the network. Cycle detection is an undirected graph in minimum spanning tree. Thank you. Now we will go to the code. Now I will explain code to you. First, we create a class graph, then we add number of nodes and then number of edges. Then we will create a parameterized constructor. Then we will add a function. We will add a function to add edges to the graph. Then we will use breadth first search algorithm, a searching technique. Then we will use a function to count the number of nodes of the graph. Then we will create a graph with the given vertices and then maintain a adjacency list that is right there. Adding a number of nodes and then adding edges to the graph. Then we will link source to its destination, which is right there. Now BFS algorithm will be explained by my group member.
As my group member mentioned before, that adjacency list. So the reason that we have used this list is because it is space saving. In adjacency matrix, we have to fulfill the spaces for every result, whether it is true or false. So we have used adjacency list here so we can get a space saved. So now I'm going to explain the breadth first search algorithm. So here's the function of graph, and we have used the scope resolution operator there. It's breadth first search and for the start vertex, as I have explained in the presentation of the dry run. Then we used a for loop which iterates the number of vertices, and here they applied the bool condition. If the visited of array I is equal to false, then it will make that value false. Now here is the queue function, and the next is the visited start vertex is equal to true, then queue push back start vertex. There is the while condition not equal to queue empty, int current vertex is equal to queue front. So the current vertex will become equal to the queue front. Now we have to see out the value and it will print visited the current vertex, and then we use a queue pop function. Now again we used a for loop for the adjacency vertices and if loop for the visited vertices. Now in the main source code, we have the two graphs. One is graph G and other is G1. So as you can see, both graphs are not same. They have different number of nodes. So if we run this program, you can see we get that our graphs are not equal. So this is the total outcome of our project. So we have came to know about that our graphs are not equal. Thank you.